Dear students, we are dealing with chapter number 4, structure of an atom. Right now, the chapter we will start with a very nice thought, that is never give up. Never give up. Whatever the hurdles are, whatever your problems are, you should never give up. You have to try hard till you get success in that particular level. So with that thought, we will continue our chapter number 4, that is structure of the atom. Let's start. Now, Bohr's model of an atom. Now, already we have studied two models, right? J.J. Thomson and Rutherford. I hope you remember. Bohr's model of an atom, there are two very important postulations, that is, only special orbits known as discrete orbits of electrons are allowed inside the atom. That means surrounding the nucleus there are a special type of orbits known as discrete orbits where the electrons are present. While revolving in discrete orbits, the electrons do not radiate energy. This was given by Bohr. But in the Rutherford, he told that the electrons are radiating energy, so it will make the atom unstable. But here it is not radiating energy, so automatically the atoms, the elements will be stable. These orbits are called energy levels. Now, these orbits we are represented, and Bohr gave certain representations like K, L, M, N, and the number of the order of these shells are 1, 2, 3 and 4. Now we will have the structure. You can see the structure, you can see these are the different orbits, right? K shell, L shell, M shell, N shell. That means 4 energy shells. Now in the middle they are the nuclear structure, that means nucleus where protons and neutrons are present, and on surrounding that the first shell K, L, M, N, that is number 1, number 2, number 3 and number 4. I hope you understood, right? Now next comes, what are neutrons? So already we have got the from these models we understood that there are different types of subatomic particles, that is protons, electrons and neutrons. So we are getting this, that is neutron. So let's go with the neutrons, that is what are neutrons? Let's start with that. Yes, neutrons were found by J. Chadwick in 1932, and you all know it is present in the nucleus with the protons, and neutrons have no charge. They are neutral and they are represented by N. Atomic mass, when you calculate the atomic mass, there the number of protons and the neutrons plays a very important role. So when you are calculating atomic mass, you have to add on protons and neutrons number. So very important role in the atomic mass. Now we are going to compare the three subatomic particles, that is electron, proton and neutron. Let's see. Electrons, they are present outside the nucleus, that is they are present on the energy shells, and they have the charge, that is negative. Remember dear students, negative 1.602 into 10 to the power minus 19, that is the unit charge minus 1, and mass, that is atomic mass unit, that is 0.00055, compared to other it is the smallest one, and mass in grams 0.00091 into 10 to the power 24. Now when we are going for protons, it is present in the nucleus, also neutron present in the nucleus, so both are same. Now protons, you have the charge positive dear students, positive. So 1.602 into 10 to the power minus 19, these are all same, that is the numbers are same, so easy to remember. This is positive 1 when atomic mass unit, if you are taking 1.00727, so larger than the electrons, and you will have the mass in grams, very important, right? 1.67262, easy to remember, 1.67262 into 10 to the power 24. Now when you see the neutron also 1.67 but 493, that means little larger than the protons, and 10 to the power 24 minus 24 is same. So easy to remember these numbers, very easy, right? Now coming to how the electrons are distributed in different orbits. Distribution of electrons in different orbits given by Bohr and Bury rules. So what are the rules? Maximum number of electrons present in a shell is given by 2n square. This is 2n square. That means you have to calculate 2n square, then only you will get how many electrons can come here. That is, n is a shell number. For example, n is 1, that means k shell. So 2n square, 2 into 1 square, that is 2 electrons it will come. Okay, 2 electrons. Then again, the maximum number of electrons that can be accommodated in an outermost orbit is 8. Remember, this is the stable condition, that is octet. So every element which need to be stable should have the outermost element, outermost electron, it should be 8. Okay, so that is why it is like that. Electrons are not accommodated in a given shell unless the inner shells are completely filled. Before filling the inner cells, we cannot go further. So whatever electrons we have to fill first, right? So this is very important, dear student. 2n square, 2n square. So based on this n, you can find out the number of electrons each shell can do. Right? The electrons present in the outermost shell of an atom are called the valency electrons or valence electrons. Now this topic is very important, dear students. When you are writing the electronic configuration, the outermost shell contains how many electrons, which that will decide the valency of that particular element. And what is valence in common? It is a combining capacity of the atoms or their tendency to react and form molecules with atoms of same or different elements. Now remember, valency means it can give electrons or take electrons. For example, if I am taking nitrogen, it has 7 electrons. So how to write the electronic configuration? K will be 2, L will be 5. That means 2 plus 5, 7. So 5 is the outermost electrons, number of electrons. So to make it octet, how many electrons it needs? It needs 3 electrons. Now remember, electrons, 5 electrons giving and become stable is much harder than taking 3 electrons only to reach octet. So the valency of nitrogen will be 3. Remember, these are very, very important concepts, right? Now, their combining capacity or valency is 0. Now, whose combining capacity, right? This point is very important. Atoms of elements having a completely filled outermost shell shows little chemical activity, right? Now, those elements, for example, neon, dear students, neon. Neon has 10 electrons. So, if you fill the electronic configuration, 2, 8. So 8 plus 2, 10. That means outermost shell is completely filled, stable. So it doesn't need to react with any other form or any other element. So that is why it is given that the combining capacity or valence is 0. Okay. So these are the inert gases, noble gases, which have the completely filled outermost shell. For example, we know the number. Now we are going to calculate the number of electrons, outermost electrons. So hydrogen, it is 1. That is the outermost shell will be 1 only. That is the valency will be 1 only. And magnesium, it is 2, dear students. Some magnesiums, the atomic number is 12. So how to write? 2, 8 and 2. So 8 plus 2, 10, and 10 plus 2, 12. So magnesium, the valency will be 2. Now remember, why 2? Because to give 2 electrons and become stable is much easier, unless we are taking the 6 electrons to become octet. So it is easy to give 2 electrons, that is why. Now therefore the valency of hydrogen is 1 and it can easily lose 1 electron and become stable. On the other hand, magnesium is 2 and it can lose 2 electrons easily and also attain stability. Hope you understood the valency. Now coming to atomic number, dear students, whenever atomic number is given, always remember number of protons, small p. Now atomic number means the number of protons. So what it is denoted by Z. So number of protons, Z. For example, if I have the number of protons 7, that means my atomic number is 7. If I have the number of protons 8, my atomic number will be 8. So same, very similar. Very simple. Total number of protons present in the nucleus calculates the number of or atomic number. That is, carbon is 6. That means atomic number also will be 6. Number of protons is 6. Now mass number. When mass number is coming, you have to calculate or remember P plus N, that is proton plus neutron. Remember, proton plus neutron. So what is a mass number? The number of protons and neutrons constitute the mass number. That means when you are calculating adding the protons and neutrons, you will get the mass number, that is weight. And when these two are together, they are known as nucleons, protons and neutrons. For example, carbon 12, so neutrons will be 6 and protons will be 6. The sum total or a number of protons and neutrons will give you the mass number. So atomic number and mass number, very very important. Now I show the diagrammatic representation. See here, the upper side, where is, yeah, you can see the upper side, the 14 written, that is left side, upper side the 14 written is the mass number, and below left side it is the atomic number. Remember, this is the atomic symbol notation. That means the upper left hand always write the mass number, and the bottom left side it will be atomic number. So when this type of elements written, you should know that what it is. Yes, now coming to isotope. Isotope, whenever this word comes, no, remember the number of atomic numbers are same. That you have to remember. Whenever isotopes you hear, you should remember that they have the same atomic number, and these elements are also same. So what it is? The atoms of same element having same number of atomic number but different mass number, dear students, different mass number. So very important, same atomic number but different mass number and same element. So isotope means same atomic number. Okay, and because they have the same atomic numbers, they are pure substance, and chemically they are similar, but physical appearance they are different. So what are the uses? There are a lot of uses. Okay, now coming to the structure, dear students, these are the isotopes. You can see H11. So bottom side, as I told you, it is the atomic number. Here also atomic number, here also atomic number, same. But see the mass number. Now mass number, how to calculate? By calculating the number of protons and neutrons. So see here, one proton, so one mass number. Here one proton plus one neutron, so 2. And here one proton plus 2 neutron, that is 3. So see, atomic numbers are same but the mass number is different. One more example for you. See carbon, the atomic mass are same, atomic numbers are same, that is 6, but the atomic number, atomic mass is different. Atomic numbers are same, see 6, but atomic mass are different. And mass number always is calculated by addition of P and N, that is protons and neutrons. There are many uses. Okay, nowadays isotopes play a very important role in medicines, different industries. So I have just written 2 3. Okay, the fuel of nuclear reactors consists of uranium, very very important, which is playing a very important role in nuclear fusion and fission. And for cancer treatment, cobalt is very very necessary because it destroys the malign tumor cells. And also the treatment of goiter, right? This isotope of iodine is used, and for spacecraft purpose there is the use of plutonium, very very important, right? Now coming to isobar, dear students, isobar, whenever isobar is coming, you should remember they have same mass number, but they have only same mass number, the elements are also different. Okay, so what is the definition? Atoms of different elements with different atomic number but having same mass number is known as isobars. Let's see the diagram. Okay, just see the diagram, it will be more easy for you compared to the written form. See, here you can see the sodium and magnesium elements different but see the mass number, that is 24 and 24 are similar, but the atomic numbers are different. And see, remember dear students, element is also different, the atomic number is also different, only mass number is similar. So they are isobars. Here you can see argon atomic number is different, even the elements are different, argon and calcium, only the atomic masses are same. So very important, isobars. Hope you understood.